So hi everyone, welcome to Online Biochemistry, and in today's session we are going to see about acid-base regulation. This acid-base is a very interesting topic in a clinical point of view as well as your MCQ point of view also. It's a very easy topic, but only thing is you need to understand the concepts. So please listen to this. It involves integration of lots and lots of information and concepts together. And first I'll be discussing about the regulation of acid-base balance in your body. Then we'll subsequently be discussing about the acid-base pathologies. Okay. And then after that, we'll see about interpretation of any kind of a acid-base disorder using a lab value. Okay, using a ABG value. Okay, arterial blood gas value. Okay, so with this, we just move on into today's session, that is acid-base regulation. Okay, so you all know what is pH. pH is the negative logarithm of hydrogen ion concentration. Okay, so what is the significance of this negative? It means what? If the hydrogen ion concentration is very high, it means what? Thing is acidic and your pH will be very low, and vice versa. If there is low hydrogen ion concentration, then the pH will be high. So it is that point which emphasizes this negative. Okay, so it is negative logarithm of hydrogen ion concentration. Okay, so what is the normal pH in your body? The pH is ranging from 7.35 to 7.45. To be precise, you can write it as 7.36 to 7.44. This will be your normal pH in your body. Okay, 7.35 to 7.45. You should be wondering how such a very narrow pH range is getting maintained in your body. This range means what? If the value is less than 7.35, if pH is less than 7.35, so what do you call this condition? You call this condition acidemia. This is the process. So this is acidemia. If the pH is more than 7.45, what do you call that? You call that alkalemia. Are you clear with this? So two new terms, acidemia, which is your pH less than 7.35, and your pH more than 7.45, you call that as alkalemia. Clear? So you should be wondering, how come our body is maintaining such a narrow pH? Why pH maintenance is extremely important, guys? Do you have any idea? Do we have to maintain the pH in your body? Is it necessary, or is it just in comfort? It's absolutely needed. It's absolutely necessary. Why? Just because most of the proteins in your body, most of the enzymes in your body are proteins, obviously, and they will be active in a physiological pH only. Okay. If there is a slight change in the pH, that is, if the pH slightly decreases and it shows, it moves on into the acidemia range or alkalemia range, it means what? Majority of your proteins and enzymes in your body are not going to function at all. Okay, so that's why that range is called as the physiological pH range. Okay, so if it is more or less, it is going to be dangerous. If the proteins or the enzymes are not functioning in your body, it means what? Your body is basically stopped functioning. It means what? You are facing a grave penalty or death penalty. Are you getting the point? So the pH, the maintenance of pH is extremely important. So we consume lots and lots of weak acids, something like curd you have through diet, and lots of proteins are getting metabolized in your body. Okay, urine is reabsorbing some hydrogen ions. It is reabsorbing most of the bicarbonate ions. It depends upon your water intake. If you are dehydrated, you pee lesser when compared to that of a colder place. Okay, so all these complex things can have an impact in your pH. So your body has to be extremely foolproof with regards to maintenance of pH. The pH has to be maintained at any cost. There is no other go. Okay. Now that we have seen the pH, we have seen two important processes, acidemia as well as the alkalemia. We move on into the mechanism of how this pH is getting maintained. Now that we have seen the process of both acidemia as well as the alkalemia and also the range of the normal physiological pH, we just now move on into the mechanism by which this narrow pH is getting maintained in your body. Okay, so we have got different systems in your place which actually helps to maintain this pH within this narrow range. Clear? So they are buffer systems. Second one is regulation by organs. Okay, the first one, regulation. Regulation is by buffer systems, and the second one is by the organs. We'll see one by one now. So buffers. Buffers are the one which actually resist the change in pH. So it acts as something like a cushion so that it helps to maintain the pH even you add acid or you add a base. Say for example, you have some kind of a liquid in your beaker and the pH of this liquid is between 7.35 to 7.45. Okay. And now you add acid to this liquid. Okay. Now, once you add an acid, it means what? The amount of H plus ions in the acid is way higher. It means what? Once you add this to that liquid in the beaker, it means the amount of H plus ions in that liquid is also going to get increased. That again implies what? There should be a decrease in pH, which is going to be expected in that liquid in the beaker. Okay. Now, if, for example, say that beaker with the liquid is also having a buffer in it, it means what? You add an acid, you add a very strong acid, that buffer helps to cushion that hydrogen ion effect. In that way, it tries to maintain the pH between 7.35, I mean the original stipulated pH. That is your 7.35 to 7.45. Similarly, you add an alkali to this. Okay. So once you add an alkali, you expect an increase in your pH value. But in the presence of buffer, this increase in pH value will be resisted and the pH will get maintained. So that is called as a buffer. Clear? Now, our body naturally has got various different kinds of buffers, and these buffers acts as a first line mechanism. So they act as a first line mechanism. Okay. And what is the second major thing? The action of this buffer is very quick. Once it is very quick, it can last very momentarily or short-lived. Okay. So these are the characteristic features of